All right, ladies and gentlemen. So second assignment. These two videos should be pretty quick. I know I keep saying that. This should be, but this one should actually be very quick. Now, here's the thing. We've been dealing a lot with graphs and points and tables and graphs, and we've been looking at really specifically one type of relationship, right? We did a lot of linear stuff where it had a special relationship between the x and the y. Every time the x went up, the y went up the same way. We also started to look at with exponents how it's not constant, but it's a relationship. It's just gonna get bigger or smaller, but it's gonna get bigger faster. Those are both relationships. Any set of points or on a table as points on a graph like these ones, which we'll do on the next assignment. They're all relations. They're all considered relations. But, so I can just plot, what you're looking at here is just a bunch of points plotted, 4 points plotted. Any points, any line, anything is considered a relation, but what we want to start to do is which relationships are we looking for? Do they have what's considered a special relationship? Is it a function? Okay, so that's what we're looking for, and it says function, yes or no. Each one of these is a relation. They're all relations, but which ones are actually functions? What does that mean? That a function is a special type of relationship. Now, a linear equation or anything that's linear is a function, and here's why. It's a function if the x, think of it like a machine. With a relation, you plug in, or an equation, we'll say an equation, you plug in a number, you get something back. So for example, when I plug in 1, I get -2. When I plug in -2, I get 0. When I plug in -1 into the machine, it gives me a 2 back, and when I plug in a 1, it gives me a 3 back. A function is going to be when our machine only gives one number for the number we put in. As in, if I put in a 1 and it gives back a -2, every time I plug in a 1, it has to bring back a -2. Every time I plug in a -2, it gives me a 0 every time. If there's a repeat of an x with a different y, it's not a function. So let's take a look. Now you might have to zoom in on these. I know I'm going to have to. And it's not really letting me. Cool. Okay. I can see this now that I moved it closer to my face. What we have? We have a point. We have 1, -2, -2, 0, -2, -1, 2, and 1, 3. We can even write it out like this, just so we can organize it a little bit better, maybe see it a little bit better. And here's the problem. Does every x give a unique y? As in, when I plug in a -2, I get a 0, right? If I plug in a -1, I get a 2. But if I plug in a 1, I should only get one thing back. And I don't. If I plug in a 1, I get a -2 or a 3. That's not okay. So if these repeat, if an x repeats with a different y, it's not a function. So here's what you're going to do. You're going to highlight which one it is. It's a no. And explain. And the explanation is as easy as there is a repeat for the x, or I don't like that. There is a repeat, and that's what we're looking for the x's, but what do we want to say? We want to say that there is not a unique y for the x equals 1. So for x equals 1, that's the problem. Make sure you identify the problem, which is 1. There is not a unique y, as in there's 2 y's for the 1. All right, let's take a look at the next one. 1, 1, 2, 2, 3, 5, 4, 10, 5, 15. Now, keep in mind, there's no pattern here. These are just points. These are just points. And what you're looking for is, are there any repeats on the x? There are not. It goes 1, 2, 3, 4, 5 on the x. So is it a function? Yes, there are no. So explanation, no repeats. How about this? No repeat x values. I know I'm typing some different stuff there, but I think that's a good way to say it. There are no repeat x values. And here there is a repeat x value. So if you want to say that too for this one, that's fine too. All right, now on a table. Bunch of different stuff. 4 goes to -2, 1 to -1, 0, 0, 1 to 1, 4 to 2, 9 to 3, 16 to 4. There are two problems I see here. And that is that 4 goes to -2 and 2. That's enough of a problem, but also 1 goes to 1 and 1 goes to -1. So that means that each x does not have its own y. In fact, some of these x's have two y's. So is it a function? Answer is no. And the reason why is x equals 1 and x equals 4 have two y values. And actually, you can say two different y values. You should probably say different just to make sure. Two different y values. All right, last one. Now, this is a little bit a weird thing here. What this does is it puts all of our x's, all of our x's here and all of our y's here. Now, you could write these out as points. So the point 3 negative, there's a point. It's 3, -2. There's 1, 0. There's 0, -1. Here's the problem. There's two arrows coming off of 0. 0, 0. So those are the 4 points. So there are 4 arrows, so there should be 4 points. Now, you don't have to write out the points. You could just see, hey, look, the x0 has two things coming off of it. That means that it is not a function. And you can see right here, there's a repeat. 0, -1. When we plug in 0, we get -1, but we also get 0. That's a problem. So we say, no, it's not a function. And the explanation, make sure that you point out what the problem is. Don't just say, there's a repeat. No, it's that x equals 0 has two y values. All right, that's it, guys.